Hello and welcome back, guys. So today we will be doing some logarithmic questions as I had posed a poll in my previous video in the comment section, and most of you said that they wanted logarithmic questions. So today we will be doing some very basic questions, and we will be just implementing some rules of logarithm that we have studied before, and this would be simple because such questions won't be coming in your paper directly, but the concepts would be there in your paper. Okay, so first of all, we'll just do two parts from this. We have 10 parts over here, so let's just do let's say this one, fifth part. Okay, fifth part. So it is 2 log a3 minus 3 log of 2 to the base a plus 4 log. Also practice saying these things so that also enhances your understanding of what you're talking about. Okay, because it is a log of 1 and we have written this base a to differentiate other logs of 1 as well. Okay, and we discussed this in our lesson video of logarithms. You can check it on my channel. Okay, so now how to solve this thing. So first of all, what we need to do is we need to understand the question, that is simplify. Okay, so simplify basically means that we need to collect like terms and all. So I can see that all of these are bases a. Okay, so for bases a we have a simple rule: when there is a minus we have to divide, and when there is a plus sign we multiply. Okay, we multiply the powers. So first of all, we need to make sure that this is 1 for everything. We have 2, 3 and 4 over here. So what do we do here is that log of 3 to the base a, and this 2 comes over here as the power 2. Okay, so this becomes 3 power 2 minus log of 2 to the base a, and now 2 power 3, plus log of a to the log of 1 to the base a power 4. Okay, so now what we do is we simplify the powers. Okay, so what would happen is that log of 3 power 2 is 9 minus log of 2 power 3 8 a to the base a plus log of 1 to the base a. Okay, so now that is simple. We have a minus over here and we have a plus over here. We can do either way because we have to, in board mass we can do addition or subtraction, either one of them first, so it won't make a difference. So what we will do is log of 9 over 8 to the base a plus log of 1 to the base a. Okay, so log of, and anyways just remember one of the rules, that whenever this is 1, the power over here is 1, the answer is always 1, right? Any base, anything, the answer is always 1. So that is why, no, that is not the rule, I'm so sorry. The rule is that if we have 1 as a base. Okay, so over here we'll simply multiply, right? Log of 9 over 8 to the base a, and that would be our answer because times 1 won't affect anything, so we will write it as it is. Okay, so that is our fifth part. Now let's do the now let us do the 10th part. Okay, because usually what happens is the last part is the most challenging one, like as a convention, it's not necessary. Okay, so 1 over 4 log of 81 to the base a plus log of 3 log of 1 over 4 to the base a minus 2 log of 3 over 4 to the base a. Okay, so how we will solve it is that first we will do this is the same thing, like the question is very similar to the previous one. Okay, so first what we'll do is that we will write it as log of, also you can practice all these questions at your own. You can just take a screenshot or something or pause the video and you can practice all these questions. If you want the answers, I can upload it on my channel. Okay, so it would be 81 power 1 over 4 plus log of 1 over 4 power 3 to the base a minus log of, it's just now fractions over here, so it would be a whole power. Okay, 2 to the base a. Okay, now we will have 81 power 1 over 4, so that is basically is equal to 3 log of a 3, because 3 power 4 is equal to 27 times 3, and that is 3 times 7 1, 3 times 2 6, and 2 and 8, yeah, 81. So that is why this answer is 3. After just counter checking, you can do it on your calculators with ease. Okay, so this is 1 over 4 plus log of a, and it is 1 over 4 whole cube, so it would be 1 cubed over 4 cubed, and 4 cubed is let me just think, 16 times 4, and that is 4 2 4 64. Okay, 1 over 64 minus log of 3 square is 9 over 16 a. Okay, so that is how it's done. Okay, so log of 3 over 64 minus log of a 9 over 16 a is equal to log of, now we have a minus, so we will divide 3 over 64 divided by 9 over 16 to the base a. Okay, you can simplify it independently over here as in rough working. Okay, 16 over 9, because when we have multiplied, the denominator becomes a numerator and the numerator becomes a denominator. Okay, so it would be 9 would cancel out, this would be 1, this would be 3, this would be, if we divide it by 16, this would be 1, and this would be 4. Okay, so it is now simple that it would be 1 over 12. Okay, now you can write it as log of 1 over 12 to the base a. Okay, so these are the two parts. Let me just import another question. Okay, so now we have another question in front of us. Let's now try this one. Okay, so it is that without using calculators. Okay, so here we have a restriction that we won't use calculators, because in one of the papers we don't have calculators allowed. Okay, so we need to evaluate LG 41 over 35 plus LG 70 minus LG 41 over 2 plus 2 LG 5. Okay, that's a simple question, because this is very similar. Basically, LG, you need to remember that LG is the same as log of anything, like for example LG4, so log of 4 to the base 10. This log of to the base 10 remains constant, and that is written as LG, okay, in short form. So now that we have this question, we will dig into it in detail. Okay, so LG, let me just make it thicker. LG 41 over 35 plus LG 70 minus LG 41 over 2, you can write brackets over here, plus 2 LG5. Okay, so it is a similar question, but we need to do the all the drill remains the same. First we need to see there are no coefficients, like the coefficient is 1 over here, 1 over here, 1 over here, but 2 over here, right? So what we will do is we will write the rest as it is. 41 over 35 plus LG 70 minus LG 41 over 2 plus, now we will do LG 5, and now it is 2 would go over here, so it would be 5 squared. So I won't write 5 squared, I'll just write 25 directly, so it saves you time and working. So what we will do is, now that we will see what are adding and what are subtracting. So these are adding, these are subtracting. You can do it independently because there is plus minus only, so that doesn't matter whatever order we apply. So I'll just do it. 41 over 35 times 70 minus LG 41 over 2 times 25, because there's a plus over here, so that would be times in these two, and over here that would be times this two. Okay, and the minus in between. Okay, so what will happen is that 41 or 35, I can just do it in my rough, that this would be 2 and this would be 1. So 41 times 2 would be 82. You can do it on calculators. No, in fact calculators are not allowed, so you can do it on your rough working over here, that 41 over 35 times 70. When we divide that by 70, this comes 2, this comes as 1. Okay, so it would be 41 over 1. That can't be written, that is like, that doesn't matter if we write it or not, and that would be 82. Okay, so this would be LG 82 minus LG, and now we have 41 over 2 times 25. So what do we do over here? What about we keep it as it is? Yeah, that could be done. Let's just let's just keep it as it is, like 41 times 25. 41 times 25 times 2, because it is a very lengthy working. I'll see if when we make this as a common log, when we take this as a common log, as one log, we can write it. Okay, so 82 divided by 41 times 25 over 2. Now you can come in your rough working over here, and you can write the same thing, 82 divided by or multiplied by 2 over 41 times 25. Okay, this is just rough, you can erase it later or whatever you want to do. Okay, so now what we can do is that we can easily see that these are two common. 41 times 2 is 81. Okay, so what we will do is we will divide by 41, so this would be become 1, and this would become 2, so numerator would become 4 over 25. Okay, and that is our answer, LG 4 over 25. So that is it for this question. Let me just do another question, because it's fun and it's easy, plus it is building your concept. Okay, so this is a very interesting question. I challenge you to pause the video right now and solve it on your own. If you do it, that's a huge achievement, and that way you are really good with the basics of logarithm. Okay, otherwise I'll do it on our own. Okay, and together, and I'll also show you the working and reasoning behind it. Okay, so if you want, you can just pause the video, otherwise we can just begin. Okay, so in front of us is this equation, and it says that a equals to this entire thing, which I'm not writing again, or I can write again. Let's just say that a is equal to, let me just thicken the pen, a is equal to log of 64 to the base 63 times log of 63 to the base 62 times log of 62 to the base 61, and so on until, I'm not writing the entire thing, I've missed one term over here, but it's okay. So until it is log of 2 to the 3. Okay, so it is log of 3 to the base 2. Okay, so what we have to do is find the value of a. Okay, so what we need to do over here is that we need to remember a rule that we studied, and that is change of base. For example, if we have a log of b to the base a, we can write it as log of b to the base c over log of b to the base a. Okay, so that is how we can introduce a new base of c, or of sorry, this is c, my bad. So this is c, and so that way we can introduce a new base of c. Oh, I'm so sorry, this is a. Yeah, so this way we can introduce a new base of c with our powers b and a. So we divided this into two things, and the similar rule would be applied over here as well. So if we have a, you can just take any base, any number, you can say any base. Let's just take 10, because if we have log of anything like log to the base 10, as we saw, it would be LG, right? So it would be less time taking to write LG. Okay, so what we would do is that we can write a is equal to LG 64 over LG 63, and that is just me dividing the term, or this term, writing this, breaking it down with a new base, that is 10, which I'm not writing. Okay, then we would have a multiply. Then I would have LG63 over LG62 times LG62 over LG61, and then we would have times LG 61 over LG LG 61 over LG 60. Okay, so that is how we can do it. So if you have an idea, you can cite it in the comment section. Okay, now we have a dot dot dot. Now over here we see a pattern, right? That the denominator over here becomes the numerator of the next term, right? So denominator, then the numerator. So this means that LG60 is the numerator of the next term. That's okay. So if we have the next term as LG3 over LG2, I'll write it over here, LG3 over LG2. That means that the numerator, what would be the previous term? It would be the denominator over there, right? So it would be the denominator. Denominator would be LG3, okay, and the numerator would be what is the numerator? 60. Then we have the numerator as 60 plus 61. 61, the numerator 62. 62, the numerator 63. So we are adding 1, right? So it would be LG3 plus 1 LG4. Okay, so that is how we break it down. So now it is very simple. We need to see that this is LG63, this is LG63, so we will cut this same things. Okay, now we have 62, 62, 61, 61. 60 would also be cut with something over here which is in the dot dot dot, which we can't see because these are so many terms that we have to write. So but it would still be cut because the next term is LG60 over LG59, so that way it will be cut. Okay, this and the last term over here is LG3 would also be cut because LG3, LG2, 3, and LG4 would also be cut because the previous term would be LG4 would be in the denominator, right, as we just saw. So LG4, when it is the denominator, we will cut those both LG4s. Okay, so we will cut the LG4. So now we are left with LG64 over LG2. Okay, and if we evaluate this, what we can see is that LG64 can be written as 2 power 6, right? Because 64 is as 2 power 6, so LG 2 power 6 over LG2. And as we saw, that is when we have the coefficient, when the log has a coefficient LG2, let's say, so the coefficient becomes the power, right? So but when a log has a power, as in this case, it becomes the coefficient because both are equal. So it could be the other way around as well, LG2 over LG2. So LG2 cancels out. Okay, so the answer we have is 6. So A is equal to 6. Okay guys, that is it for the video. Thank you for watching. Bye bye.